Okay, so in this example, I'm going to be discussing two things. The first thing I'm going to be discussing is where is it centered at, and where does it converge? Where what values of x does it converge at? Well, so what I'm going to be looking at specifically is, first off, I know it's centered at 0. The reason why I know this is centered at 0 is because if the series looked more like this, then that would be centered at 0, at a 2, not 0. So I know the series will be centered at 0. Now, the first thing I do when I come across problems like this when it comes to the power series is I always want to think about where is it centered at and will it converge there? Because no matter what, all these three, it will always converge no matter which situation we're given at very, very bare minimum C. So our C in this case, our center, is 0. And that's one of the first 4 problems on the homework I want you all to be doing, is to be working on where is it centered at. That's it. Okay, so I know it's centered at 0, so I'm going to think about 0 first. So if it was centered at 0, sorry, this series should be from 1 to infinity. Forgive me. So if it was centered at 0, I would get continually get 0 over and over and over and over and over again. So I know the series converges, and this series and equals 0. So the series will converge at 0. I don't need to worry about that. So I know part 1 is true. Okay, but I do need to check the other part. I need to check number 2 now. So the way I'm doing that is I'm going to use what's called the ratio test. Now, we discussed this in the last section in 9.7. So let's go ahead and do that. And we know, just as a reminder, that there's 3 possibilities for the ratio test. If the limit an plus 1 over n, an, if it's less than 1, it converges. If it's greater than 1, it diverges. And if it equals 1, it's inconclusive. So I'm going to keep these three things in the back of my mind. If it's greater than 1, converges, less than 1 converges, greater than 1 diverges, equal to 1, inconclusive. So that's what I'm going to do. I'm going to go ahead and do the ratio test now. So we're going to take the limit as n approaches infinity of n plus 1 factorial times x to the n plus 1 divided by n factorial times x to the n. Or do the absolute value of that. Okay, I'm going to go ahead and simplify this to the best of my ability first. So then what I'm going to do is I'm going to go ahead and limit as n approaches infinity of n plus 1, n factorial, x to the n times x divided by n factorial x to the n. Okay, absolute value. And I know this is going to simplify right here. So here I'm going to go ahead and use a different color pen to signify my reduction here. N plus 1, x to the n, x to the n. So I am left with the limit as n approaches infinity of n plus 1, the absolute value, times x. Now I know this piece right here is always positive, and then we don't know necessarily what the x value of x is. But x is constant. We're going to think about this individually. So what happens at x equals -2? What happens at x equals positive 100? We have to consider every single value. I'm dropping the absolute values at n plus 1 because I know it's positive. All right, so now I know that, look, sorry, look what's happening here. This guy, no matter, as the n approaches infinity, will be infinity. So no matter what we do here, it will always diverge. So this thing always diverges. So in this particular situation, this example, we have the first case of our convergence. The series will only converge at x equals c. So that means that for this series to converge, x must equal n factorial. Sorry, I have to write out the problem. That's it. It's the only spot in which it converges. Okay. So now we're gonna go on to example number 2. I'm going to go ahead and go through this one just a little, you know what? I'm not going to have time to go through this whole entire example, so I'm going to go ahead and stop the video, and then we'll be in the next one.